This video will present you on the implementation of our product Detecto, which has the ability of detecting gas leakages. First, let's move on with our motivation of the project. A gas leakage in a household LP gas cylinder and also other gas usages in a commercial activity can cause major issues, which has been currently recorded frequently with very high damages to the personnel as well as property. And also, such gas leakages results in an energy loss too. Therefore, our objectives of the implementation is to save personal lives, property and the surroundings, and also to overcome the loss of energy during a gas leakage. Now, let's take a quick look at the working principle of Detecto. During the initiation of a gas leakage, the MQ2 gas sensor plays its role by detecting the gas leakage and then sending signal to the Atmega 328P microcontroller to communicate with the A6 GSM module to warn the user with the gas leakage. The components used in our product is as follows: a MQ2 gas sensor, A6 GSM GPRS mini module, Atmega 328P microcontroller, PCB, and passive components like resistors, LEDs, connectors, capacitors, a 16 MHz crystal oscillator, as well as a 9-volt battery. Now let's move on with the component specifications of Atmega 328P microcontroller, MQ2 gas sensor, and the A6 GSM GPRS mini module. First of all, let's take a look on the Atmega 328P microcontroller specifications. The pinout diagram is shown here, which was made use of during the implementation of the Arduino board circuit in a PCB, and also for the connections of the MQ2 gas sensor and the A6 GSM GPRS mini module with the microcontroller. The following specifications of the microcontroller were made use of during the product design. The operating voltage of the microcontroller is 1.8 to 5.5 volts and the current flow details during various modes are as follows. During the active mode, the current is 2 milliamperes. During the power down mode, the current is around 0.1 microamperes. And the power saving mode, current is around 0.75 microamperes. Next, let's move on with the MQ2 gas sensor. The pinout diagram is as follows. The first pin is used to connect to the ground. The second pin gives us a digital output. The third pin gives us an analog output. And finally, the fourth pin gives you to connect to the VCC. The specifications of the MQ2 gas sensor is as follows. The circuit voltage of the sensor is around 5 volts, where the tolerance can be of 0.1. The circuit voltage can either be AC or DC, and the load resistance of the sensor can be adjusted. This flow diagram shows the basic steps involved during our product implementation phase. As a start, we first programmed our microcontroller to test for the A6 GSM GPRS mini module, where we coded it to function in a way such that a push button press initiates a SMS message to be sent to a predefined number. Secondly, we moved on to the testing of MQ2 gas sensor functionality. Therefore, we programmed the microcontroller to switch on a LED and sound a buzzer when the MQ2 gas sensor detects a gas. Next was the designing and implementation of the Arduino board. We have not used an Arduino board in our product design, and instead we have implemented it on a PCB, which is according to the circuit following. Then we link the codes of the A6 GSM GPRS mini module and the MQ2 gas sensor tested beforehand to function as a whole to achieve our project scope. This is the coding that we have used for our gas leakage detector. Here we are using the library Sifter serial, which is capable of inserting our own functions and commands in my serial. Also, this library supports RxTx pins of any GSM module with the digital pins of the Arduino. The only thing we have to define is the pins in my serial port. We are giving the inputs as the analog sensor to the analog side and the push button to any digital pin on the Arduino. And outputs as red LED, green LED and the SMS alert to the phone number we are entering. First, we have to open the serial communication between the GSM module and the Arduino. Here, we use 115,200 bits per second as the baud rate, which is compatible with the A6 GSM mini module. After setting the data rates for the software serial port, we can communicate with each of the modules and the sensors. So, in order to send the SMS, we called a function name SMS. The function consists of at commands, and the delays between the lines produce a time duration to send the SMS when the gas is detected. So, as to terminate this leakage identification, we use a loop. Inside the loop, we compare the input value of the MQ2 gas sensor with the threshold value we are entering to detect the gas leakage. If that input value reaches the threshold given, the gas leakage is detected and the red LED lights will light up while the SMS is sent to the user to notify. And also, we use the push button condition to check whether the A6 GSM mini module works properly by sending a SMS to the user when the push button equals to 1. Finally, our gas leakage detector, Detecto, was implemented successfully as follows. Currently, our product has the capability of sending a SMS only to a predefined number. But this project could be further developed to a product which could take user inputs of user preferred phone numbers using a dial pad and send SMS messages to them. Finally, I'd like to thank you all for watching our video.